Welcome back, everyone. Today we'll be looking at section 4.6 on variation of parameters. On this one, we're not going to get too heavy into the proof part of it. We're just going to kind of look at the setup and how to make it work. So the format that we want, so our form, we want it to be of the leading coefficient of 1. So we'll generally just be working with double primes on this, although it can be used in higher order than that. So the idea here, we'll look at an example and see kind of what we do with this along the way. We're going to use some Ronskins on the variation of parameters method. Let's take a look at y double prime plus 4y is worth 2x. And initial conditions, y of 0 is 1, y prime of 0 is 2. First thing we do on this is find yc. So in other words, we solve the homogeneous equation within this. So m squared plus 4 is equal to 0. M squared is negative 2. M squared is negative 4. M equals plus or minus 2i. So yc would be c sub 1 cosine of 2x plus c sub 2 sine of 2x. So our real number coefficient was 0, so we don't have any e to the powers involved here. Our first Wronskin with this, we're going to use y1 and y2, y1 prime, y2 prime. So for this problem, y1 is cosine of 2x, y2 is sine of 2x. So y1 prime, negative 2 sine of 2x, and y2 prime, 2 cosine of 2x. So w is equal to, so now we multiply on the downward diagonal, and we get 2 cosine squared of 2x, minus, multiply on the upward diagonal, negative 2 sine squared of 2x. Minus a negative, then I'll flip the sign, so our Wronskin is 2 times cosine squared of 2x plus sine squared of also 2x. Cosine squared theta plus sine squared theta is 1, so w is equal to just a nice pretty 2. So this variation of parameters method, we then are finding W1 and W2. W1, we replace the first column with 0 and f of x. Second column we leave alone. So for this problem, 0 stays, f of x is, in this case, a 2x. Second column looks the way it did before. So 0 times anything is 0 minus 2x sine of 2x. So w1, negative 2x sine of 2x. And we find w2 in much the same fashion. 0 and f of x, replace the second column instead of the first column. So first column appears as it did before, cosine of 2x. Derivative of which is negative 2 sine of 2x. And then we have our 0 and f of x in our second column, so 0 and 2x. So 2x cosine of 2x on the downward diagonal minus 0 on the upward diagonal. So our W2 is 2x cosine of 2x. So highlighting the key stages, we found YC. We find W, W1, and W2. Let me just bring what we know to the other page. So we know that YC was C1 cosine of 2x plus C2 sine of 2x. We learned that W was worth a nice, neat, pretty 2. That W1 was negative 2x sine of 2x. And that W2 was 2x cosine of 2x. So another given bit of information from this is what to do with the Wronskian once we get it. U prime 1 is going to be W1 over W, U2 prime similarly defined. So W1 negative 2x sine of 2x over 2. So minus x sine of 2x is U prime 1. So U1 would be the integral of that, integral of minus x sine of 2x times dx. And we can do integration by parts here. So our different u, integration by parts, u is negative 1x, so du is negative 1, dv is sine of 2x. So v is negative 1/2 cosine of 2x. So u1 is equal to negative by a negative kicks us over to a positive, so x over 2 cosine of 2x minus integral of v times du. Two negatives again kick us over to a positive. 1/2 cosine of 2x times dx. So u1 x over 2 cosine of 2x. And then integral of cosine of 2x is half sine of 2x. We already have another minus half, so minus 1/4 sine of 2x. So U2 prime described in much the same way. W2 over W. Again, I'm not going to ask you to run through a proof on why these things work. Just kind of practice with getting them to work, and that's plenty enough work for this section. 2x cosine of 2x over 2, which is x cosine of 2x. So U2 is the integral of x cosine of 2x times dx, and again, just an integration by parts problem after that. So again, different u, integration by parts, u is x, so du is 1 dx, dv cosine of 2x, so then v is half sine of 2x. We didn't have the sign change on there since the derivative of sine is positive cosine. So then u2 is equal to half x sine of 2x minus integral of v times du, half sine of 2x dx. So then u2 is 1/2 x sine of 2x minus 1/2 times integral of sine of 2x is negative 1/2 cosine of 2x. So u2 would be half x sine of 2x plus a quarter cosine of 2x. Now how these variables are related, yp is going to be u1 times y1 plus u2 times y2. So our particular solution, u1, we found on the other page to be x over 2 cosine of 2x minus a quarter sine of 2x. So there's our u1. y1, if you'll recall, was the cosine of 2x. Plus u2, half x sine of 2x plus a quarter cosine of 2x times y2, call was sine of 2x. So yp, we'll do a little distributing. We have x over 2 cosine squared of 2x minus 1/4 sine of 2x cosine of 2x. Again, I'm writing a little too big, so we're going to wrap it around down here. Distributing again, we have plus x over 2 sine squared of 2x, and then plus 1/4 sine of 2x cosine of 2x. So we can definitely do a little cleanup on that. Definitely the minus 1/4 and plus 1/4 are the same thing. Those will drop. We can factor an x over 2 from the next pair, and then we have cosine squared of 2x plus sine squared of 2x again. So yp is x over 2. So now what we have is yc, we figured out was c1 cosine of 2x plus c2 sine of 2x. We have yp up there, so y equals c1 cosine of 2x plus c2 sine of 2x plus x over 2. So if they didn't give us initial conditions, that's where we stop. This time they did give us a couple of initial conditions, so we'll keep rolling on this one. So we know that y of 0 is 1 and y prime of 0 is 2. So we'll just bring that to the top of the next page. Y of 0 is 1, y prime of 0 is 2. Okay, and our solution. Y was c1 cosine 2x plus c2 sine of 2x plus x halves. Okay, so we'll just plug in what we know for now. 1 is equal to c1 cosine of 0 plus c2 sine of 0 plus 0 over 2 is still 0. So sine of 0 is also 0. So 1 equals c1 cosine of 0 is 1. So c1 is equal to 1. The next one we need y prime. So y prime is equal to, derivative of cosine is negative sine, so negative 2c1 sine of 2x. Derivative of sine is cosine, so plus 2c2 cosine of 2x. And derivative of x over 2 is a half. And then we plug in what else they gave us. So y prime of 0 is 2. So 2 is equal to negative 2 c1 sine of 0 plus 2 c2 cosine of 0 plus a half. So 2 is equal to sine of 0 is 0. That knocks this guy out completely. We have a 2 c2 cosine of 0 is just a 1 plus a half. So 4 halves minus 1 half is 3 halves. So 3 halves is 2 c2. So c2 is worth 3/4. So then our solution, y1 is equal to c1, 1, cosine of 2x plus c2 plus 3/4 sine of 2x plus 1/2 x or plus x over 2, whichever way you'd like to write it. Okay, so some of these can get a little bit on the messy side, but this is, we kind of follow the same procedure each time. Again, this last page was only if they give us some initial conditions. Then we go through and find C1 and C2. But our main ideas, find YC, find our Wronskian, W1, replace with 0 and f of x in column 1, keep y2's column the same. So u prime 1, w1 over w, u prime 2, w2 over w, and you can solve it from there. So that's our sort of general flow of the problem. Again, some of them do get a little bit on the messy side. So in 4-6, I would recommend trying out 1 through 21 on the odds. If you have any questions, please get in touch with me. Otherwise, I will see you next time.